Have you ever stopped and wondered what is actually happening inside a computer when we say it's learning? I mean, it sounds kind of like magic, right? But it's not. Today, we're going to pull back that curtain and look at the simple but incredibly powerful engine that drives so much of modern AI. Let's get into it. And this is really the core of it all, isn't it? As humans, we see patterns everywhere, totally intuitively. But a computer, it starts as a complete blank slate. So how do you teach it to connect the dots? To see an input and know the right output? How do we give it something that even remotely looks like intuition?
All right, we're going to start small, like really, really small. We're going to build our learning machine with just one single simple unit, what we call a neuron. And our goal is to teach this one tiny neuron how to do a very, very basic task.
Now, the key word on this slide, the one you really need to remember, is weight. You can think of these weights as little adjustment knobs, like the volume or tuning knobs on an old radio. The entire process of learning is just about finding the absolute perfect setting for each and every one of these knobs.
So that's our mission. Find the perfect settings for our weights and another little knob we call a bias, which you can think of as a fine-tuning dial. It all sounds pretty straightforward, but when there are practically infinite possible settings, where in the world do you even start?
Well, let's try the most human thing we can think of first. Let's just guess. Yep, pure trial and error. We're going to pick some random numbers, see how well they work, and then hopefully use that result to make a slightly more educated guess the next time around.
You got to start somewhere, right? So let's just pull some numbers out of a hat for our weight, W, and our bias, B. How about a weight of 0.5 and a bias of, let's say, 0? Let's plug them in and see what happens. Okay, so we've plugged in those numbers, and our little neuron spits out what we call an error score. In this case, it's 0.073. The easiest way to think about this score is as our how wrong are we meter. A score of 0 would mean we're perfect, so our goal is to get this number as close to 0 as we possibly can.
So, 0.073. It's not the worst, but it's definitely not 0. So what's our next move? Well, let's just nudge the knobs a bit. Let's make the weight a little bigger, maybe a little smaller, and just see what that does to our wrongness score.
And would you look at that? Our second guess actually made things worse. The error went up. But then, look what happens. We try pushing the weight up and the bias down, and that error score starts to fall. It goes from 0.07 down to 0.02, and then all the way down to 0.0028. We're getting warmer. So it actually worked. Just by guessing and kind of following our gut, we got really, really close to the right answer. But you can probably see the problem here, can't you? This is slow. It's clunky. It relies on a whole lot of luck. For a network that has billions of these knobs, just guessing is completely impossible. There has to be a better way.
And of course, there is. So let's forget about guesswork for a second. Let's explore a much smarter, much more elegant way to learn using a fantastic analogy. I want you to imagine you're a hiker lost in a super thick fog, and your only goal is to find the lowest point in a huge valley. This landscape you see, this represents every single possible guess we could ever make for our weights. The height at any given point on this map is the error score for that specific guess. Our job as the hiker is to find the absolute lowest point. But here's the catch. The fog is so thick you can't see more than an inch in front of your face. You can only feel the ground right underneath your feet. So, what do? It's actually really simple, really intuitive. You start wherever you happen to be standing. You feel the ground with your feet to figure out which direction is the steepest way down. You take one small step in that direction, and then you just do it again and again and again. Every single step is guaranteed to take you just a little bit lower. And this intuitive process, this hiker in the fog technique, has a formal name. It's called gradient descent. Now, gradient is just a fancy mathematical term for the direction of the steepest slope. So all we're doing is calculating the slope and taking a tiny step in the opposite direction, downhill. This, right here, is probably the single most important algorithm in all of deep learning.
So our single little neuron with its clever hiker algorithm is great for simple problems. But what about the really hard stuff? Recognizing a face in a photo or translating a sentence from one language to another. For that, we need to scale up, big time.
Here's the key thing to understand. A single neuron is like having one perfectly straight ruler. It can only solve problems by drawing one straight line to separate things. We call these linearly separable problems. But most real-world problems, they're messy, they're complicated, they're non-linear. No single straight line is ever going to solve them.
So what's the solution? Well, if one neuron can draw one line, what happens if we add more? By connecting neurons together in layers, the network can learn to draw incredibly complex, curvy, nonlinear shapes. The first layer might learn to see simple things, like edges. The next layer combines those edges into shapes, and the next layer combines those shapes into objects, and so on, until it can recognize incredibly complex patterns.
But here's what's so amazing, what's truly mind-blowing. Even in a gigantic network with billions and billions of weights, the fundamental learning process is exactly the same. It's still just our hiker, but now they're in a billion-dimensional space, feeling for the steepest way down to make that error score just a little bit smaller.
This one simple idea, repeatedly taking small steps downhill to get a little bit less wrong, is the engine that enables all of this. Understanding your voice, translating languages on the fly, analyzing DNA sequences. It is all powered by this one simple, beautiful idea of gradient descent.
So, that's how a machine really learns. It's not magic. It's just a simple, powerful, elegant process of getting a little less wrong one step at a time. And it leaves you with a pretty fascinating question, doesn't it? If this simple journey downhill is the core of machine intelligence, what are the limits? What other valleys are out there, just waiting for us to explore?